Hi everyone. So on Thursday we talked about fractions and we stopped at the practice problems. So we were doing this problems and I just want to continue on that topic and show you a couple of more things that we can do with fractions. So um, remember when we were looking at 18 over 24 and we wanted to bring it to the lowest terms, we broke down 18 into 2 times 3 times 3 and 24 into 2 times 2 times 2 times 3. We see that we can cancel by 2 and cancel by 3, both of the numbers on the top and the bottom. And the leftover would be 3 over 2 times 2, which is 3 over 4. So this is one way we can bring down the fraction into the lowest terms. Another way would be, so let's look at the same problem, 18 and 20 over 24. So we know that both 18 and 24 are divisible by 6. So we can write it right away, not even going to the prime factorization, but to the number that is not necessarily prime, but we know that both numbers are divisible by that number. So we can write 18 as 3 times 6 and 24 as 4 times 6. And as you can see, both 6 and 6 in the top and the bottom can be canceled. So we are again, when we have 6 over 6 canceled, there is just 1 that's left. So we have 3 over 4 times 1, which is 3 over 4. So this would be in the lowest term. So these two fractions are equivalent. All right. So now we also looked at the decimals. We did a couple of examples and we saw that, let's say 0.4, that's the same thing as 4 over 10, 0.40, right? It's 40 over 100. So we usually don't write these zeros after the significant figure. So this 4 would be a significant figure. What does it mean? It's any number that is not zero, essentially. The last number in the last digit in the after decimal point, that is not zero. So in this case, it's going to be 0.4. 4 is the significant figure here, or 0. Or maybe even 1.345. So 5 would be the last significant figure here. So we don't have to write any zeros here. If, for example, we have a number that is 1.3450001, in this case, this 1 would be the significant figure that we should write. Okay, if there is nothing after it, or if there are zeros, we can skip them. We can just omit them and don't write them. Okay. All right, so we also worked with 0.6, converting it into the fractions, and 0.125, we tried to convert it into fraction, and we got 1 over 8. Now, uh, let's look at the rules here. So converting a decimal to a fraction. So first we need to identify the place value of the last digit in the decimal. So we have here an example, 2.345, right? And 5 is on, we need to figure out what place value 5 is located. So we have tenth, hundredth, thousands, right? So 5 is at the thousands place. So now, if there is a number to the left of the decimal point, it is the integer part. So this would be the integer part, and it is left unchanged. We don't do anything with that. So if there is a 0 point, something like this, 0.345, there is no integer here, right? So we will just write it as, we'll just write this 345 as the numerator for our fraction. But if there is an integer here or a number to the left of the decimal point, that would be our whole number. Now, second step, we will write the decimal as a fraction using the place value of the last digit as a denominator, and then write the fraction in the lowest terms. So in this case, we have 2.345, right? So 5 is at the thousands place. So that means that in the numerator we have 1,000. In the denominator we have 1,000. In the numerator we have 345. And then we can reduce it, well, at least by 5 from what I can see, but we'll just keep it like that. So let's do practice problems. So we have here 0.1, 0.01, 0.003, and 3.757. So let's convert it into the fractions. So 0.1, we see that 1 is located at the 10th position. So that's going to be just 1. So this number goes to the numerator, and its place would be the denominator. So if it's 10th, then we have 1 over 10. Here, in the second example, we see that 1 is located at the 100th position. So our denominator would be 100, and the 1 would be in the numerator. So we don't write any zeros in front of it. Now 0.003, we see that the 3 is located at the 10th, 100th, 1000th position. So denominator is 1,000, and 3 would be in the numerator. So we have 3 over 1,000. Okay. And then we have another example, which is 3.757. First of all, 3 is a whole number that is on the left side from the decimal point, so we just keep it unchanged. We just leave it as it is. And then we look at 757, right? So the last 7 is located at the thousands position or place. So we would have a denominator 1,000, and the numerator would be 757. Okay? All right. So now let's go to round in the decimal. So let's say we're given a number 3.685. And we want to round it to the nearest hundredth. So first what we need to do is we need to locate the digit at the 100th place. So in this case, we have 6 is a 10th place, 8 is a 100th place, 5 is a thousandth place, right? So we need this 100th place is 8. So we want to round it to this point, to this location. Now, from here, if the digit after the digit of interest is greater than or equal to 5, if it's 5 or more, we add 1 to the digit of interest, and then we drop everything else. So in this case, we see that 5 is greater than or equal to 5, right? So it's 5 is equal to 5. So that means that we will add 1 to this 8 and drop whatever is on the right side. So in this case, we would have from 3.685, we would get to 3.69. So 5, we don't need it anymore. But since 5 is greater than or equal to 5, we add 1 to 8, which becomes 9. So we have 3.69. Okay. Now, if the digit after the digit of interest is less than 5, then we leave the digit of interest as is and drop everything after. So let's say you see the difference. We did before 3.685. Now, let's say, for example, we have 3.683. So the only difference is this 5 and 3, right? And we want to round to the nearest hundredth. So the digit of interest is this 8, right? Now we look at the 3. 3 is less than 5, so we don't add 1 to 8. So we will just drop 3 and that's it. So we will have 3.68. So 8 stays as it is. Okay? All right. So now let's practice a bit. Given a number 0.2973. So let's do different examples with this number. So let's round this number to the nearest thousand. So thousand is, so this is tenth, hundred, thousands place. So digit of interest is 7. So we'll look at this at the next digit, which is 3. 3 is less than 5, so we'll leave 7 as is. We don't add 1 to it. So the final answer would be 0.297, and we just drop 3. Now, if we want to round the same number to the nearest hundredth, again, 10th place, 100th place. So 9 is the number that we will be rounding. So, sorry, the place that we will be rounding. So what we need right now is look at the number that is right next to 9, which is 7. We compare it to 5. So 7 is greater or equal to 5. So we know that it's greater than 5. So we add 1 to the digit of interest and we drop everything else. So 7 and 3 will be dropped, but 9 becomes a 10, right? So then that would mean that we need to also change our 2, right? So 2 becomes a 3, and we would have 0.30, or we can also, as we said, don't write 0, and we have just 0.3. Okay, and now if we want to round to the nearest tenth, again, 2 is the position of interest. We look at the 9, or the digit that is right after 2. 9 is greater than 5 or equal, so we add 1 to the digit of interest, which is 2, so we get 3. So we have 0.3, and the rest would just drop. Okay, another example. So this number is a bit bigger this time. So we have 2.932458. Okay, so now I want us to round this number to the nearest 100,000. Or we don't say that. We usually say round the number to 5 significant digits. What it means is that we have 1, 2, 3, 4, 5 up until here, 5 significant digits or figures. Okay, so we want to drop this 8, but first we need to look at that to see if we need to add 1 to 5 or not. So again, we see that 8 is greater than or equal to 5, so we add 1 to our digit of interest. So we have 2.932, and then this 5 becomes 6, okay? Because 8 is greater than or equal to 5. So that's why this 5 becomes 6. We add 1 to it. Okay. Now the same number, but now let's round it to 10,000s. Again, we don't say it like that. We usually say round it to 4 significant digits or significant figures. So we have 1, 2, 3, 4. So this number 4 is the digit of interest. And now let's look at the next digit after it. It's 5. So the condition is 5 is greater than or equal to 5. So we add 1 to our digit of interest. So it becomes 2.932. And now since 5 is greater than or equal to 5, we add 1 to 4. So that becomes 5. All right. Now next problem. We want to round the same number to the nearest 100 or 3 significant digits. So 1, 2, 3. So we will be rounding up until 2. Now let's see if we need to add 1 to this 2 or not. So the next digit after 2 is 4. 4 is less than 5. So we leave this 2 as is. We don't add 1 to it. So we would have just 2.9 932, and that's it. And the rest is just dropped. Okay, so this is our final answer. Now, I want to round the same number to the nearest hundred or two significant digits. Again, we have the same number. We look at the second significant digit, which is 3 in this case. So 9, 3. I want to round it like that. Now, I want to drop the rest of it, but I need to first look what I'm going to do with this 3. Do I add 1 to it or I leave it as it is? So I look at the 2, the very next digit to the right of the digit of interest, which is 2 in this case. It is less than 5, so we'll leave 3 as it is. We don't change it, right? So we'll just, basically, we just drop the tail and we'll leave 2.93 as it is, okay? Now, I want to round the same number to the nearest tenth, or one significant digit. Again, I look at the 10, it's 9, so everything after it, I want to truncate, or I want to just drop it, right? But before that, I need to check if I add 1 to my 9 or not. So I look at the number that is, or digit that is right next to the 9 to the right. It is 3, and 3 is less than 5. So I leave 9 as is. I don't change anything. So I have 2.9. And the last example would be, I want to round the same number that we were given to the nearest whole number, to the whole number, okay? So I don't want it to be in this huge decimal format. I want it to be just a whole number. What do I do? So this, the number that is before the the decimal point, that's gonna be my whole number, right? Because after that, that's going to be my decimals. This is the whole number. So again, I look at the number that is right next to the digit of interest. If it's greater than 5 or equal to 5, I will add 1 to it. If not, then I leave it as is. So we have 9 here. 9 is greater than or equal to 5, so we add 1 to my digit of interest, which is 2. So 2 becomes a 3. So when I round 2.932458 to the nearest whole number, I get 2, okay? All right, so now let's look at the comparison of the decimals. We will be doing that a lot, especially closer to the end of the semester where we will go over hypothesis testing. So I want you to feel comfortable comparing the decimals. Okay, so we start at the left and compare digits in corresponding decimal place, left to right. And then when two digits in the same decimal place are not equal, the number with the larger digit is the larger number. Okay, so let's look at the example. Oops. So we have 2.04 and 2.038. Which one is greater? Which one is larger number? So first we start comparing the first digits, which are 2. So these are at the same location. These are whole numbers. These are the same, so we move on to the next digit. So next digit that we will compare are zeros, right? So zeros are the same. Again, we move on. Next one would be 4 and 3, okay? These digits are both in the 100th position, but 4 is greater than 3. That means that this number 2.04 is greater than 2.038, okay? So first ones were the same, second ones were the same, but the third digits are different, and this one is greater. So the whole number would be greater than this one, even though this one has more digits. Okay, next example. 0.06 and 0.59. Which one is greater? So first we compare the first digits, which are 0 and 0. They are the same. So we move on to the next number or digit. So next one is 0, here 5. So 5 is greater than 0. That's why 0.59 is greater than 0.06. Okay? All right, another example. Here we have 0.04 and 0.043. Which one is greater? So let's compare. 0, 0 are the same. 0, 0 are the same. 4 and 4 also are the same. Now here we don't have any more values, right? Or any more digits. Here we have a digit. So remember that this 0.04, that's the same thing as 0.040, and which is the same as 0.0400. And you can write how many zeros you want. We just don't usually write that. So what you can do in this case, you can write our 0.04 as 0.040. And now, since these two are the same values, we compare the next values, which is 0 and 3. And we see that 3 is greater than 0. So this number, 0.043, is greater than 0.04. Okay? So this is how we compare the decimals. All right. Now, next thing that I want to show you is the notion of absolute value. So the absolute value of a number a, written as a in this bars, right, is the distance from 0 to a on a real number line. So this is the real number line. It's the same thing essentially as a ruler, but it also goes to the negative direction. Okay, so we locate, we locate 0 on our number line. When we go to the right, this would be 1 unit, 2 units, 3 units, 4, 5, and so on, units to the right. And when we go to the left, that's going to be 1 unit to the left, 2, 3, 4, 5, but we write it with the negative sign. So that's going to be -1, -2, -3, and so on, right? So when we write a number in these absolute values, or these bars, that means that we are going to a units to the right and to the left of the 0. So let's say we have absolute value of 2. That means that we go 2 units to the right, so it's going to be +2, and also 2 units to the left, which is also 2. So -2, that's going to be 2. +2, that's 2. So essentially what it means is that all the negative signs inside of the absolute value bars disappear, okay? So this is just the distance, and distance is a positive value. So let's compute. So if we have absolute value of 6, that's going to be just 6. If we have absolute value of -8, so as I said, this negative sign, it just disappears in the absolute values because we're looking only at the distance. So we would have 8. 0 absolute value, that's 0. So that's essentially we stay at 0 and we don't move anywhere to the left and to the right. Okay, now let's look at this one. So we have negative absolute value of -1.8. Well, first of all, this negative, it will disappear, right? Because it's inside of the absolute values. So this just disappears and we have 1.8, but there is this another negative outside of the absolute value that we need to keep. So that's why this negative, it is also transferring to the answer. So we have -1.08. But this negative inside of the absolute values, it disappears. Okay? All right. Now, I want us to do some mathematical operations on fractions. I want you guys to feel comfortable doing that. You can definitely use a calculator for that, and I'm totally fine with that. But we just need to know what is, how it's done manually, and don't be confused with these operations. So let's say we are given the values or the numbers 3/7 and 2/5. We want to multiply them together. So to multiply them, we multiply the numerator separately, and then we multiply the denominator separately. And then we reduce the fraction if needed. So we have 3 over 7 times 2 over 5, right? So what we do is we just multiply 3 times 2, and we multiply 7 times 5 separately as well. Okay, so 3 times 2, that's going to be 6, and 7 times 5 is going to be 35. So since 6 and 35 don't have anything in common, no common factor, these are already in the lowest terms. Okay, so the rule is the following. So if we have A over B times C over D, then we just multiply A times C and B times D with the condition that B and D are both not equal to 0. Okay, now let's do an exercise. So let's say we want to multiply 4 over 9 times 21 over 8. So what we can do is we can just multiply the numerator separately and denominator separately. So we have 4 times 21, which is 84, and 9 times 8, which is 72. Now we know that both of these numbers are divisible by 12, right? So we can write it as 7 times 12 over 6 times 12. Now we know that we can cancel 12 because they both match in the numerator and denominator. So we are left with only 7 over 6. And that would be in the lowest terms. Now, another way to do that is to reduce the fraction first and then multiply. So sometimes it might be easier to do the reduction first. So we have 4 over 9 times 21 over 8, the same exactly setup as before. But now we know that 9 and 21 are divisible by 3, both of them. And we know that, 4 and 8 are both divisible by 2. So we can reduce the fraction already. So we can write 4, actually 4 and 8 are divisible not only by 2, but by 4 as well, right? So we can write 9 as 3 times 3, and 21 as 7 times 3, and 8 as 4 times 2. As you can see, we can cancel 4, we can cancel 3, and the only survivors here would be 3, 7, and 2. So we write it as 7 over 3 times 2, that's 6. So we have 7 over 6, the same thing as we had before, okay? All right, so now let's do a practice problem. So we have 1 over 2 times 3 over 4. What we can do, we just multiply 1 times 3 and 2 times 4, and we get 3 over 8. So 3 over 8 have no common factor or multiple, so we leave it as is because this is already in the lowest terms. Now another one, 5 over 8 times 2 over 15. So we see that 5 and 15 can be reduced by 5 because both are divisible by 5. And 2 and 8 are both divisible by 2, so we can reduce the fraction as well. So we will write 8 as 2 times 4. We will write 15 as 5 times 3, and we can cancel 2's, and we can cancel 5's. And we are left with only, so in the numerator, as you can see, we canceled everything. But as I told you in class, if we cancel everything in the numerator or denominator, that doesn't mean that there is a 0. It's always this hidden 1. Okay, it's never 0. If we cancel everything anywhere, it's not 0. It's 1. Okay, the same thing as if we, let's say 6 over 6, right? When we cancel 6 and 6, it's not a 0 here. It's gonna be 1, okay? So please keep that in mind. So in the numerator, we have 1, and in the denominator, we have 4 times 3, so that's gonna be 12. So we have 1 over 12, all right? Okay, so now another example is 6 over 6 over 11 times negative 7 over 8. Okay, so now in this case we have a negative value. Now when we multiply two values or two numbers, one of which is a negative number, the final answer would be also negative. If we multiply two numbers, both of which are negative, then negative times negative becomes a positive. Okay, so this is the rule that you need to also keep in mind. So let me write it here. So negative times positive, that's gonna be a negative value. Negative times negative, that's gonna be a positive value. And we also know that positive times positive, that's also a positive value. Okay, so these rules, please remember, or calculator can do that for you as well. Okay, so we have 6 over 11 times negative 7 over 8. Since one of the values is negative, we just take that negative to the front so that it doesn't, interfere with our calculation. And we just calculate the values. Now, another thing, notice that 6 and 8 are divisible by 2, both of them. So we will write 6 as 3 times 2 and 8 as 2 times 4. And we can cancel 2 and 2, right? So we would get 3 times 7 and over 11 times 4 with the negative sign as well. So we would have 21 over 44. And this is, I believe, in its lowest terms. So we keep it as it is. Now the same problem, but now 6 over 11 is also negative. So again, the same thing. We calculate the same way, but just these two negatives, they multiply by each other and they make the final answer positive. So the final answer will be the same thing, 21 over 44, but now with the positive sign because both of the original numbers were negative. So negative times negative will be a positive. Now, if we have a fraction multiplied by a whole number, what do we do? So we have 3 over 2 times 4. Now, when we have a whole number, let's say 4, this is the same thing as 4 over 1. So when we have a denominator 1 in this case, it's always like that with the whole numbers. So even if you have something like 2, that's the same thing as 2 over 1. If you have 100, that's the same thing as 100 over 1. So every whole number can be written as a fraction in this way. Okay, so when we have 4, we can write it as 4 over 1. Now we have two fractions where we can multiply 3 times 4 and 2 times 1, right? But before that, we see that 2 and 4 are both divisible by 2, so we can cancel the 2 here in the denominator and the numerator. So we would have 3 times 2 over 1, right? So we have only, essentially, we have 6 over 1. Oops. And we said that any number divided by 1, that's just the whole number that we have. So this is going to be just 6. Okay? And the last example is 4 over 5 times 2. Again, 2 can be presented as 2 over 1. So we have 4 over 5 times 2 over 1. So nothing can be canceled or reduced, right? Because 5 and 2, they don't have anything in common. 4 and 1, when 1 cannot be canceled any further, right? So we just multiply the numerators and denominators, and we have 4 times 2, that's 8, and 5 times 1, that's 5. So we have the final answer is 8 over 5.